So good morning. So we are going to take operation research problems, especially students from MBA and other commerce background students facing a lot of hurdles in getting through this kind of subjects. So I'm going to take today problems from the linear programming problems. So first today we're going to see the simplex method. So here a simplex method. There is two kind of problems. One is maximize, another one is minimize. So here the conditions to find the optimal solution in maximization problem and minimization problem here. In maximization, the condition for optimality is Zj minus Cj should be greater than or equal to 0. In some books they will follow Cj minus Zj less than or equal to 0. But you have to go by, I just want to make ensure that maximum should be greater than or equal to 0. That's why I am using this way of calculations. In minimization, condition for optimality, here Zj minus Cj less than or equal to 0. So to align with our objective functions, I am creating this optimality as per the objective functions. So for these two things, we are going to test in the iteration process. So let's go to the problem. So I'm going to take one problems from the maximization case. So you can able to understand where are all you people make mistakes. So here, especially in operation research, you people make mistakes in the calculation part. You may know the methodology to solve the problem, but you will make mistakes in the calculations. So I will pinpoint where are all you people make mistakes. Now we begin with the problem. So objective function of this problem is maximize c equal to 6x1 plus 8x2 and subject to 5x1 plus 10x2 less than or equal to 60 and 4x1 plus 4x2 less than or equal to 40, where x1 x2 are non-negatives, which means x1 x2 value should be greater than or equal to 0. So they given the constraints of they have to find the optimal value of x1 x2, but they given the constraints that 5x1 plus 10x2 should be, when we multiply x1 and x2 with 5 and 10, it should not go beyond minimum 60 we should get. So to first we will do this. The given problem is a canonical form. So the first step in the problem we're going to do, we're going to convert this inequality into equality. So that step we will call step 1. So converting canonical form into standard form, which means we are going to convert either lesser than or greater than or equal to type. So in especially in simplex method, generally all will come in the less than or equal to type. In big M method, two-phase method, we will come with the greater than or equal to kind of inequality. So you can straight away assume that in examination perspective, they won't say sometimes whether it is simplex or big M or two-phase. But how we are going to able to identify when all the constants are given in the less than or equal to, we will say this is simplex method. So now to make this left hand side is equal to right hand side, since the left hand side of the equations are lesser than the right hand side. So further we are going to add one slack variable s1 in the constraints. We will now take the objective function maximize z equal to 6x1 plus 8x2 in subjective constraints. The first constraints are going to 5x1 plus 10x2. To make it equal to 60, I am going to add slack variable s1. So that the left hand side lesser value, that small amount will be added here. Similarly, in the second constraints, 4x1, 4x2, make it equal to 40. I am going to add another slack variable s2. For naming conventions, we are giving the sequence order s1 and s2. Now, so to know when we are going to use in the iteration, we will use, since we had two slack variable, for every equation we have to show that two slack variables. So here we didn't add anything, so we will keep with zero coefficient in the equation. And here also we can use 0 s1. It doesn't make any values here in the equations. For naming conventions we are keeping it. So take, this is equation 1, this is equation 2. Now, so to convert, this is the standard form. One more things we need to add in the objective function here. S1 and S2, two slack variables we added in the equation in 1 and 2. These two equations I have to add in the objective function with 0 coefficient. 0 S1 plus 0 S2. So this is the canonical form. This is the standard form. So now we are going to find the initial basic feasible solution. So now we converted into standard form. The next step we are going to find initial basic feasible solution. Simply we will say IBFS. So to find initial basic feasible solutions, we are going to substitute non-basic variables equal to 0 in the equation on 1 and 2. Here non-basic variables are x1 and x2. So we are going to substitute. So non-basic variables. So x1 equal to 0 and x2 equal to 0 in equation 1 and 2. So what happened from the equation 1? It gives phi of 0 plus 10 of 0 plus s1 plus, since 0 s2 is doesn't value, we will keep as 0, is equal to 60. So from this what we will get, 5 into 0 0 plus 10 into 0 0 plus s1 plus 0 equal to 60, which means s1 is equal to 60. Similarly, from the equation 2 we will get, so when you substitute x1 equal to 0 and x2 equal to 0, what we will get? 4 of 0. So when you substitute x1 place 0 and x2 place 0. So 4 of 0 plus 0 s1 will keep 0 and s2 place, I think here equal to 40. So from this what, everything is going to be 0. 0 plus 0 plus 0 plus s2 is equal to 40, which means we will get s2 equal to 40. This is, so we obtained initial basic feasible solutions. So now next step, so to these initial basic feasible solutions or optimal solution we are going to test in the iterations. So next we're going to find the we're going to test the initial basic feasible solutions or optimal. Here optimality here first we're going from the iteration table 1. So here remember how I write, this is how you also have to create this table. First we have to write this is basic variable. Here coefficient of basic variable. Here coefficient of objective function. In objective functions, what are the variable we are given? X1, X2 and additional slack variable S2 and the quantity B are given. So here below the basis, what are the values we obtain in the initial basic feasible solution? S1 and S2, that you have to write down. So now the corresponding to the Cj, subscript Cj, which is coefficient of objective functions. So in the first phase of finding initial basic feasible solutions, what is the coefficient of x1 over there? 6. And coefficient of x2 here is 8. In objective function, while converting the standard form, s1 coefficient here is 0 and s2 coefficient is 0. Next, s1, where we got the s1 solution from equation 1. So in equation 1, x1 coefficient here is 5, x2 coefficient here is 10, s1 coefficient 1, 0. This is quantity. In quantity in the right hand side, what we got? 60. In second equation, in the initial basic feasible solutions, what is the coefficient of x1? 4, x2 4, and s1 coefficient 0, and s2 coefficient 1, and then quantity here is in right hand side 40. Now, coefficient of basis here, you just go through this. Where is S1? What is above over there? You can write here, same value. So, what is above S2? That you are going to write down over here. So, this is a basic formation of iteration table. This is how you have to create iteration table. So, our optimality conditions, you have to remember, our optimality condition here is Sfj minus Cj greater than or equal to 0 for maximum z objective functions. So our objective function is maximize. So we have to find Zj minus Cj. Cj values are given in the first row top of the iterations. How are we going to calculate Zj values? So Zj value here over here I am going to find this value. How are we going to calculate? Remember, this value I am going to multiply with this. Now inside the table value, what I will get? 10 into 5. We'll show one for one part. 10 into 5 plus 0 into 4. 0 into 4. So what happened? So 0 into 5 plus 0 into 4, all will go into, when we add, we'll get 0. So anything we multiply with 0, all will going to be 0. So now here 0 multiple with 10 plus 0 multiple with 4. So what happens? 0 into 10, 0 plus 0 is going to be 0. Similarly for this also, 0 into 1 plus 0 into 0. So when we add everything, we will get 0. For this also, 0 into 0 plus 0 into 1. What happened? This also 0. Here 0 into 60, 0 into 60 and 0 into 40. What happened here also? 0. So now, when the coefficient of objective functions values are 0, so you can completely it's going to be all simplex problems. The first iteration table Sj values by default is going to be 0. So now we are going to find Sj minus Cj value. So Sj value we know and Cj value also we know, which means 0 minus 6, what will get? Minus 6. 0 minus 8 will get minus 8. 0 minus 0, 0, 0 minus 0, 0. So quantity we don't do anything. Now we have to check with the conditions. Whether all the values are greater than or equal to 0, no. This up to this values we got either 0 or greater than 0, but there we get negative values. So in the objective functions to find the optimal solutions, all values should be more than 0, which means no negative value should occur in the Zj minus Cj rows. But here since for all Zj minus Cj values does not greater than or equal to 0, so we need to improve further. So next step we're going to do the iterations to find the optimal solutions. In this next first step, what we do? So here, what is here? Lowest value in the when we know there is no optimal solutions we obtained from the after calculating Zj minus Cj. So now we have to check among these Zj minus Cj values the lowest value in the objective optimality testing when there is no optimal solutions not obtained. So now we will go to the next iterations. We have to improve it. Here the lowest value. So among this lowest value here is minus 8. This I am going to choose as a key column. Key column value we will say is a KC for now naming and understanding. So that respective column I am going to insert it. The variable respect to the key column x2 we call as a entering variable. So next we are going to find the key row. So once we identify the key column, to go for finding the key row, here first I am going to find the ratio theta is equal to B by KCV. B means theta here is ratio, B we know the quantity, and KCV means key column values. So key column value here is, this is key column values. This we call as a KCV. So now the first row for S1 row, what is the quantity here is 60 divided by the key column value for the respective row here is 10. So 60 by 10 will get 6. Similarly for second row, 40 is the quantity divided by key column value 4 is equal to 10. So we found ratio for the each rows. The selection criteria for key row here is we have to choose the lowest positive ratio. If there is any negative ratios we obtain, we cannot take as a key row, we have to ignore it. So what are the positive value we have found? From that lowest value we have to choose as a key row. So among 6 and 10, the lowest value here is 6. So we choose as a key row. In small letters we will say KR. So that respective row I am going to encircle it. The key column and the key row intersection value we call as a key element. So key element. The variable respect to the key row S1 row, this is we call as a leaving variable. In small letter we will say LV, entering variable we will say UV. So now we're going to do the iterations. For iteration value for key row, so here iteration value for key row, how are we going to find? Row value divided by the key element. simply we will say RV divided by K. For remaining rows, for no iteration value for remaining rows, for the remaining rows, we will say row value minus key column value multiplied with iterated value of key row. Here RV means row values, KCV means key column values, and IVKR means iterated value of key row. So now we're going to apply it to find these values. So below I will do it. No, I will keep it little lower values. So to refer this, it will be useful. For this is key row, what is the value? Key row here is, what is the key row? S1. So how are we going to find the iterated value here? What are the values I have to find? X1, X2, S1, S2 and quantity B. So for S1, what is the row value for X1, X2? For S1, row value here is for X1 5, X2 10, S1 1, S2 0, quantity 60. So we know this row value divided by key element. This is the formula we are going to apply. So row value I given and key element I know it's 10. So divided by 10 for all value. What I will get here, you always use fractional, don't use decimal values. 1 by 2, 1, 1 by 10, 0 by anything 0, here 6. For next row, remaining rows, for row S2, what is the formula I told you? Row value minus key column value multiplied with iterated value of key row. Iterated value of key row is this is the value iterated value of key row. Now first I am going to write x1, x2, s1, s2 quantity b for the row values. So x1 row value for s2 here is 4. So this is p. This is where many people will confuse to find these values. So this is I created this formula for students to understand very easily while calculations. So to avoid more calculations, I make it this kind of formula. 4 for x1 row value, for x2 also 4, s1 row value 1, s2 row value x1 row value is 0, s2 row value 1 and quantity here is 40. So as per the formula, I wrote row values for all the values. Next they given minus symbol, minus, put minus for all values. And what they given? Key column values. So key column value, which means here the encircle key column value for s2 row here is 4. If it is plus 4, it will come as 4. Sometimes if they given it in terms of minus, what happen? It will become plus. So remember that. So when it is plus, it will be minus. If it is minus, it will become plus. Next in multiple with iterated value of key row. The respected x1, what is iterated value we got? 1 by 2. For x2, what iterated value we got? 1. For s1, you get 1 by 10. Here 0. Here 4 into 6. When you simplify, what will get here? 4. When you strike out here 2. 4 minus 2 will get 2. 4 minus 4, 0. Here 2, 5. So here 0 minus 2 by 5 minus 2 by 5. 4 into 0 0. So 1 minus 0 1. 40 minus 24 will get 16. So now this value I am going to substitute over in the iterated table value 2, and in S1 place it will be replaced by x2. So now iteration table 2 as per here basics, coefficient of basic variables, say here coefficient of objective function x1, x2, s1, s2 and quantity b. Here the same, it won't change. In the first row the objective coefficient of objective function won't change, it will come as it is 6, 8, 0, 0. Here what we said, s1 is replaced by the x2 and here s1 as it is will come, because x2 is entering the basis and s1 is leaving variable. Now for first row, what are the values we found here? Iterated value 1 by 2, 1, 1 by 10, 0 and 6. In second row you have to check, sometimes key row will happen in the second row, that time you have to write the accordingly. Here second row, what is iterated value? 2, 0, minus 2 by 5, 1 and 16. So now coefficient of basis, what is above in x2? 8. What is above s2? 0. Now after this we know how we have to calculate Zj and C. So we are all going to test the optimality. Now Zj values 8 into 1 by 2 plus, which means 8 into 1 by 2 plus 0 into 2. What happens? 4 times it will go plus 0, so 4. 8 into 1 plus 0 into 0, 8. So getting it first value, so no need to write here for understanding. Write down over here. Next 8 into 1 by 10 plus 8 into 1 by 10 plus 0 into minus 2 by 5. What happened here? 2, 4 times here 5. 4 by 5 plus 0 will say 4 by 5. Here 8 into 0, 0 plus 0 into 1, 0. So 0 plus 0, 0. Here 8 into 6, 48 plus 0 into 16, 0. So 48 plus 0, 48. Here we are going to find the Zj minus Cj. 4 minus 6 minus 2, 0, 8 minus 8, 0. 4 by 5, 0, 4 by 5, 0 minus 0, 0. Still there is one negative value exists. So we didn't get the since for all Zj minus Cj does not greater than or equal to 0. Again, we are not obtained the optimal solutions. We need to improve further. So here among this Zj minus Cj, what is the lowest value? Minus 2. Since only one negative values are exist, so this we will take it as a key column. We have to encircle the respective values as a key column value. So entering variable in the next iteration here is x1. So now again we are going to find the quantity ratio. We are going to find ratio formula, quantity divided by key column. Quantity here is 6. So whenever there is fractions value occur, instead of dividing we will multiply with reciprocal. Say a divided by b by c, we can write a into c by b. And one more case, so a by b divided c, you can write a by b. So keep it as division is 1, a by b into 1 by c. So this kind of things you have to apply. So 6 instead of dividing by 1 by 2, I am going to use 6 into 2 by 1, which is equal to 12. Here 16 divided by 2, what I will get? 8. Now you now look at these two ratios. Among these two ratios, what is the lowest positive? This is the lowest positive. So that I will take it as a key row. I want to encircle this key row. So intersection of key column and the key row is the key element. The variable respect to the key row is the leaving variable. So in next iteration, in this S1 place, X1 going to replace. So find the iterated values. Always you have to find the iterated value for the key rows. So here, what is the key row here? This is S2. You forgot, S1 I remember, S2. So S2 is the key rows. Here row value, what are the value? Go and find the iterated value for X1, X2, S1, S2 and quantity B. You are going to find. For row value for here X1 2, X2 0, for S1 minus 2 by 5, for S2 1, for quantity it is 60. So what is the formula for the iterated value? Row value divided by key element. So row value we written and the key element is 2. So all divided by 2 divided by 2 whole divided by 2 divided by 2 and divided by 2. So I already mentioned over here. So A by B divided by C, you can write A by B into 1 by C. So 2 by 2 you get 1, 0, 0 by, divided by anything 0. So minus 2 by 5 into 1 by 2, what happened? 2 will cancel, minus 1 by 5 you will get. Here 1 by 2 will be 1 by 2, 16 by 2 it's become 8. So iterated value for row, key row we got it. For iterated value for remaining rows. So for row X2 iterated value, how we going to find? Row value minus key column value, iterated value of key row. So this is formula going to apply over. Here first write down the row value for here. For X1 1 by 2, X2 1, S1 1 by 10, S2 0, quantity 6. So now next minus, we put minus for all values, and key column value for this, for row key column value is, this is the key column value for this row X2 row 1 by 2. So here 1 by 2 I went to write down for all values, so 1 by 2. Next, iterated value of key row, which means what you found in the above for X1 here, key row 1, multiply with 0, here multiply with minus 1 by 5, here multiply with 1 by 2, multiply with 8. So here 1 by 2 minus 1 by 2, 0, 1 minus 1 by 2 into 0, 0, so 1 minus 0, 1. Here 1 by 10 minus 1 by 2, here I will show 1 by 10. So minus into minus will become plus, so plus 1 by 10. So when you keep this 10 as a common, what will happen? 1 plus 1, 2, will get 1 by 5. Here 1 by 5. Here 0 minus 1 into 1 by 2 into 1 by 2, it will become minus 1 by 4. Here when we strike out by 2, 4, 6 minus 4, you get 2. So iterated value for S2 row and S2 we found. Here, so I am going to substitute next. So iterated table 3, So now base is coefficient of base is coefficient of objective function. Here x1, x2, s1, s2 and quantity b. Here x2 we know, but here replaced by s2 is replaced by what is the value? x1. So here first this is key rows, which is what is a key row? S2. That is in last iteration, the second value. This has to be written in the second value. 1, 0. For S1 it is minus 1 by 5. For S2 1 by 2. For quantity it is 8. For second row, next row, the x2 row, what is the value we got? 0, 1, 1 by 5, minus 1 by 4 and 2. Now coefficients we know, here coefficient 6, 8, 0, 0. What is above x2 here is 8. What is above x1? 6. So from this again the iterations will be same for every, all next consecutives. It won't change. Once you know the first iterations, the same thing you're going to follow for all the ZJ. So 8 into 0 plus 6 into 1, 0 plus 6, 6. Here 8. 8 into 1 by 5. Next plus 6 into minus 1 by 5. So what you will get? 8 by 5 minus 6 by 5. So keep it 5 common. 8 minus 6, you get 2 by 5. Next 8 into minus 1 by 4. 8 into minus 1 by 4 plus 6 into 1 by 2. So what happened? If this is 2 times, we will go minus 2. Here 3 times we will go plus 3, you will get 1. Here 8 into 2, 16 plus 6 into 8, 40. Here 16 plus 48, you will get 64. So now Zj minus Cj. Six minus 6, Zj value 6, Cj value 6, 6 minus 6, 0, 8 minus 0, 2 by 5 minus 0, 2 by 5, 1 minus 0, 1. So here all values we got plus, which means Zj since for all Zj minus Cj greater than or equal to 0, we obtained optimal solution, which is, this is the quantity, this is Z maximum when Bx2 and Bx1. So we got optimal solutions when x1 is equal to 8 and x2 equal to 2. We got optimal solution maximum z here. How much we got? 64.